Hello and welcome back. In this video, what we are going to do is try and answer one of the big questions that we talked about at the very beginning of this project. And here is a list that we came up with. One of the questions was, what are the number of delays per month? Uh, well, if we have data, so if we look at the stop times, we do have the times, but I don't think we have the dates for that. We have the year information. So maybe we could find something around delays, but then the problem is we do not have the arrival and departure times that are different. As we saw that 96% of the data has the same arrival and departure time. So that's an issue. But still, there is a way I'll discuss how we may able to get an estimate on delays. What are the types of cars that are more prone to breakdown? We do not have this information, so we cannot answer that question. Again, we already answered this question. What stations have wheelchair access? That's the ADA access, the ADA compliance that we looked at earlier. Then we have another question, which is what is the passenger capacity of each train? Again, we do not have that information, uh, but we and that would depend on the type of car, and so this is not there in the data set. We could look in external data sets, but then unless we have a way to match the type of train in this data set, we won't be able to get the capacity. Then we have the information about same information right here, budget and funding, and then we have some signaling, types of cars, platform spacious, space of platforms, parking. So we do not have any of that information in this data set. Then we have number of stations. We do have number of stations, and we already looked at that. But we do not have the distance in miles between stations. So that information, we do have latitude and longitude, but then we do not have the path distance between stations. And bus connectivity, again, we do not have that information. So based on this, the closest we can get to answering real world question is, I think, based on number of delays. And here's what I'm thinking we could do. So if you look at this map, there are several stations, and the information that we have are trips, right? So we could go from, let's say, East Chester to Morris Park. So that would be that'll have a unique trip ID, and then the good thing about this data set is that we do have the time data uh, between stations. So what I mean by that is, if we have a arrival time for East Chester, we do have arrival time in that same trip ID for Baychester. Then we have the same. We'll have the arrival time for the Gun Hill Road, then Pelham Parkway, Morris Park. And what we could do is we could get the difference in time between these stations to get how much time it takes for how much time it took for a person in that trip to go from East Chester to Baychester, and then again how much time did it take to go from Baychester to Gun Hill Road? How much time did it take to go from Gun Hill Road to Pelham Parkway, and so on to Morris Park? The what we can try and do is get that information for all the stations in here, all the stations, and that's a lot of work. If not all, at least those stations which we are able to join. For example, if we look at the stop times table, this is what has the arrival time, and we'll need that time. We would also need the trip ID, and so we could join these two to get the route ID. So that's fine. So we know that this join does work perfectly, no problems there. But the challenge is how do we get the station name in there? And so to get the station name, we could work without station name. We can just stick to stop ID, but then we won't be able to uh, uh, stop IDs could be the same in different trips, right? The first stop would be number one in all the trip IDs. So we won't be able to differentiate it that way. What we could do is we could join this to the GTFS stop ID and then get the station name from this particular table right here. We have the station name. So that would give us some information about between what stations we are trying to find the time difference, and that will be useful. So still the question that you may have is, well, we if we find the time difference between two stations, how is it going to help us find delays? Because we do not have the standard time. And that is correct. I looked up in Google, tried to find what is the average time between stations, or is there uh, a distance that is sort of fixed distance between stations, but that is usually not the case. Some stations are placed like around the same distance, but some stations are far apart, and so we cannot use some average distance to calculate in our calculations. One thing we still could do is use some statistics. Uh, We could get all the time differences and then look at the distribution of those differences and see how many data points fall outside of three standard deviations, right? And if it falls outside of that, we could think of them as outliers or potential delays, and the station that has a higher number of such delays we could be, or the routes the routes that have this high number of delays could be the routes where more attention is needed to kind of minimize this type of delays. Now this is just a thought and for this project this may or may not work, and remember that the data that we have is from 2013 to 2018, and since then a, um, a lot of upgrades must have already been done. So whatever we find out from this analysis uh, may or may not be actionable at the time of making this video. That is uh, right. So the real relevance may not be there, but it still would be relevant to the data set we are working with. So let's get started. And I haven't written the code ahead of time, as I said, just because I wanted to give you a feel for what goes on in the thinking process uh, when we start out working on finding answer for such a question. Right? It's completely abstract right now, but I'm hoping by the end of this video, we'll have some answers uh, to uh, to answers to answer questions around delays of subway. All right. So here's what we are thinking. Let's say we are an analyst and we are hired to find the stations where there are potential delays, and that's a project. And the New York subway is going to uh, like there is going to be considerable investment to improve the service and reduce delays. So what routes would you suggest that needs more attention, or what parts of the routes need more attention? That's the question we'll try to focus on. The very first thing we'll do is we'll try to pull some records from our stop times table, and this is the table we have. And in this table, we have arrival time, departure time, stop ID, stop sequence, stop head sign, and we should have, yep, the pickup type, drop off type, if distance traveled. So we do not need all of these columns. So what we need are these. We just need the trip ID. I'm going to put that here. And then we need the arrival time. So it doesn't matter at this point in time whether we pick the arrival time or departure time, because they happen to be the same in this case. So we'll pick the arrival time. Then we need the stop ID. So that's the important one. And the stop sequence. So the stop sequence tells us uh, what is the sequence of stops uh, for each trip ID. Stop sequence. And I think that's all we need. That's all we need from this table. Now, when we another point we can change is pick a trip ID that we can work with initially. And I'm going to pick a trip ID for a weekday. Let's say this one. I'm going to copy it, and for reference, just paste the trip ID up top right here. That's the trip ID, and we can filter this here. Add a filter where trip underscore ID is equal to that's the trip ID we are going to work with, and hopefully we get a list of top sequences that are okay. So we just have couple. I was hoping we could get at least 10. Let's try another trip ID. So I'm going to comment this, uh, comment that, filter out, run this. The reason for getting more another trip ID is we want at least uh, at least a few stops to get the to write our code to get some calculations going. This trip ID would also work, but if we have more, then we may be able to handle some edge cases as we write the code. All right. This looks nice. We have 10 stop sequences, and perfect. So let's stick with this trip ID. I'm going to put that here, and that's a weekday. So I've already created a new tab, named it big question. Save the query, and remember to save the query from time to time. And also you could copy this and put it in a separate notebook, then just in case if the notebook hangs. Now with this, another point we need to do is this top ID. We are going to be joining it with the GTFS top ID, and so for that from what we saw earlier, these first three characters are the same in the column GTFS top ID. So we'll use those for joining. And so here's what we'll do. We'll say substring substr stop underscore ID. Let's get the characters 1 to 3, and I'll name this also as GTFS underscore stop underscore ID and comma. So that's set. And in addition, let's now get going with joining the trips table to this. And we'll join this on the trip ID itself. So this should be straightforward. We simply put a inner join and copy this path to the table, paste it below, and call this trips. And we'll join this using a trip ID. So that's how this would be. And now when we look at, we do not need the limit because We already have a filter for a trip ID. We are not looking at the entire table, just one trip ID. Then after we perform the join, something has happened. We have more than 10. Oh, maybe without join also we have the same number of rows. I was thinking we just had 10 rows with that trip ID, but maybe I was wrong. Oh, I was wrong. We have 24 rows with that trip ID, so that's even better. The 24 rows, that's good. We perform the join and we should get around same number of rows. So we have 24 and 047. 47 minutes, that's the trip time, total time for that trip. And again, after we perform the join, we have 24 rows and that's the last time we have. Awesome. So this is good. We have these tables all set. The next thing we'll do is we need to get the station names in here, and the reason for that is uh, station names. And before we do that, we also can put route IDs. So let's do this, and we can rearrange these columns as we need. And so what we could do is I'll take the arrival time, put it right here, and write the route ID as a second column. Now to join this and this output, as can run this query and just look at the output. That's the route L, and it could happen that again, so there are going to be edge cases in what we are trying to do. If a person goes from one route to another route, and if that happens, then there are going to be delays because the person would be waiting on the station for the next train to arrive from a different route, and those could uh, pop up as outliers in what we are trying to do. So we'll see how this goes. At least we have a direction where we can start writing the code in. Next, we'll join this to the stations table using the GTFS stop ID. And to do that, we'll say select. For now, we'll say if we say star, it is going to give us all the records, so we don't need that. So instead, what I'll do is simply copy paste these and put station ID just before arrival time, or station name, sorry, station name, and this is from, and open parenthesis, and then we have a closing parenthesis right here, and indent that, and then here we can do a left join. The reason for doing a left join is because uh, we we have station names, we have more trip IDs here, and some of these GTFS stop IDs do not match with the stop IDs that we have. I think that's what's happening, um, but I could be wrong. Maybe let's try inner join first. Inner join, and we use this path, and all we need to do is change this to station. What's the column name? It's just stations using GTFS stop underscore ID, and now oh, it's I think we have this two times. So remove that and run this, and let's see if that GTFS stop ID exists, and it does. So this did work. Arrival time, we have the station names, and we do have the stop sequence that goes up to 24. As you can see, the GTF is stop ID and stop ID, they do match really well. So that's awesome. So this looks like this for this trip ID, everything works well. But if we try to perform this join without that trip ID, I suspect we won't get 19640 rows in the output. Rather, we'll get a less number of rows. Let's run this entire query and wait and oh, before or we could have just gotten count. So let's do that then. Move this up, and yes, these are going to be a lot many rows. So, but still uh, okay. So the what we have, we do have the number of results. If we look down here, we have 5, 4, 6, 2, 5, and that's more than what we have here. And what may have happened is we probably created some extra rows because this GTFS stop ID matched on multiple stop IDs. Okay, right. So that is a possibility because different trips could have the same stop ID. For example, here the different trip ID. So this is a trip ID. So this trip ID is 19. This is FS 011. This is FS 012. This is a Sunday. This is Saturday. Different trip IDs, but then both of them have the same stop IDs, and therefore that's what caused this to explode to 500,000 rows records. All right. So if that's the case, I think we'll leave this as an inner join for now. Um, uh, if we change this to left join, let's see if we use that as a left join, does it increase the number of rows even further? And here is the output. We still have the same number of records. So looks like the inner join does works just fine, and we'll stick with inner join. So that gives us more confidence that whatever uh, table that we are going to start writing the query for is does not have any issues when we perform the join. Okay, so let's bring our trip ID back in as a filter as there, and this is now the uh, query, or this is the base query that gives us the table, which is this one, that we can start using as a starting point to find delays between stations, or rather than saying delays, the time it takes to go from one station to the next in a particular trip. For example, in this case, what we would have to do is get the difference between this time, and then get the difference between this time and this time, and put that as a separate column. So let's do that. And now it's a matter of choice. Do we want to put this, use this table as is, or do we want to put this in a CTE? What I'll do is just for sake of ease for writing the code, let's put this in a CTE and call this, uh, give it a name. Uh, so let's call these delays as, and our base table delays is what we are going to calculate. So maybe A times or arrival times, but that matches with the column name. Timings, let's use timings, and that's the table we'll be referring to. And again, put a tab. So now we don't have to worry about that code anymore. It'll stay up there. All we need to do is just use select star from timings, and we should be able to write the code. Uh, Again, because there is just one query on this in this notebook or tab, what we can do is we do not have to select the query each time we run. We can simply put the cursor anywhere and run the query like so, and we will get the output. So the first thing to get the difference in time, which is right here, what we can do is this. Let's put a star so we get all the columns. Then um, to get the time, what it's the time difference from one row to the row below it, and so we'll have to use something called as lag or shift. And to calculate the lag, here's what we can write. Lag, and if you go to the docs, here is what here's what we are going to use, the lag, and we are going to use the partition for that. Lag, and then we can specify the name of column that we would like to lag, and that's going to be arrival time in this case, and by how much, so by one row, and this is going to be over, and we are going to partition it by the trip ID, and the reason is because each trip ID will have to work with it as a separate set, and so we'll partition the data, partition by trip ID, and then we'll order it. So order by, and this is going to be order by this the stop sequence, because that's what goes from, let's say, increasing order, so that should be fine. Stop sequence, and as here we can give this a new column name, lag arrival time, and let's run this. So we should now see a new column at the very end. That's the lag arrival time, and here's how that column looks like. We have the first value is null. That's because that's going to be the lag. So we shifted this value down, and what we are going to do next is get the difference of this with this. But before we do that, there's one more thing we need to do is bring in another trip ID in the same table. And so far we are just using this one trip ID. So I think to see the partition really work, we need another trip ID. So I'm going to run this code again to get trip ID. So let's run that. And here we'll pull one trip ID. Doesn't matter which one. I'll select this one, which is again a weekday, hoping that we'll have uh, at least few rows, 3-4 rows, and we'll put another condition, and, or rather than and, we need or. So uh, get me the rows, here's what we are saying, get me the rows that have the trip ID that we have listed above, or it has the trip ID which is this one. And now when we run this, we should see two trip IDs. So that's the first set, and then we have down below we have the second set, and the second set just has 1 2 3 4 5 6 rows. That's fine. One point that you'll see here in the stop sequence is this doesn't look like it's ordered by stop sequence, because 1 10 11 12 13 14, but these numbers are jumbled up, and the reason for that is I would guess that this is, it looks like an integer, but the stop sequence is still a string column. So what we'll have to do is cast it as an integer. So when we perform the order by, it works on integers rather than as a string. Cast stop sequence as int64, and I will name this as the same stop underscore sequence. Now when we run this, you should see that the the rows are ordered correctly, and this is what we were expecting. So this looks good. Again, we start at 1, the shift is working fine, these values are there. Awesome. uh, in addition, let's see, I was thinking, should we replace this null value by uh, by some other string, for example 0000, or maybe not. That may create some issues, so we'll leave that as is. Um, another another change that we'll have to do is, in each of these rows we'll also have to lag the station name. What we'll do is we'll lag the station name column as well, and then we'll try and uh, concatenate those. So we have sort of a string that says I'm going from this station to this station, and here is the time difference for that. Okay. So to do that, let's add another column, and that column we are using this. So right here, and we can rearrange this later. For now, we'll just uh, keep adding column one below other. So this is the next column. We are going to change. We are going to lag the station name by one row. Again, the same partition and stop sequence is the same. All we need to do is change the name here. We'll say station underscore name, and run this again. We should see the station names as the very last column. Awesome. So we have that. And now is the time when we can sort of concatenate the lag station name and this to give us a string that has two station names in there. And for that, what we can do is put this as another city. The first one was what we call timings, or let's say, oh, maybe timings, that's fine. This one we'll call lag time as, and then we'll say select. Now we can start dropping the columns that we do not read right now. So we do need the trip ID, so we'll keep that. We do not need the stop ID or GTFS stop ID for now. So we could drop those routes. We do not need the routes, but we could keep the route ID just to see if there are any interchanges. Maybe we'll be able to handle those. And then we need the arrival time, and then lag arrival time. But before that, we'll try to concatenate this. So concat, concat, and we are going to concat the lag station name with concat that with lag or with the station name, and uh, call this as S1 to S2. Let's just say the station 1 to station 2 as, and this is coming from the CT that we just created above, which is lag time. Lag time or times, so lag time. All right, so that should work. Yes, but then this we need to put a separator in between. So how about we add a space? If this doesn't work, we may have to write two concatenate statements. Okay, that did work. That worked just fine. Or we could put something that is cannot be used as a part of a string for any station. And so this is good. So this tells us that we are going from this station to that station and so on. Next, what we'll have to do is get the of course we need the stop sequence. So I'll add the stop sequence. Oh, sorry, stop sequence is that what we call it? Yes, stop sequence. Stop underscore sequence. So we put that in there, and then we are going to get the difference in time. And for getting the difference, we'll simply use the time underscore diff, and uh, the first column cast. This is going to be the uh, arrival time. So here's what we have. We have the time from we have the arrival time and we have then the lag arrival time. So lag arrival time is always going to be less than the arrival time, right? Because it's the previous time. And so when we perform the subtraction, we'll use the arrival time first as this is cast this as time, and then we'll cast the lag arrival time as time. Okay, so I think we are good. We have the time difference. We can perform uh, time diff unless I'm missing something. Cast arrival time, and we'll call this as delay or time diff or t diff. And we do need to specify what units. So we'll say seconds just to keep things simple. And if we want to, then we can always convert this back to minutes by dividing it by 60. And to keep the number smaller, we'll round these off to, let's say, 4 decimal places. And that should work. Second instead of seconds, and divided by 60. And I think we are in a good position to run the query. We can also add, oh, we don't need the station name because we now have a new S1 S2 station. Okay, so here we have route ID, we have the station, then we have the stop sequence, and we have the difference, time difference. This is in minutes, and let's put a minutes, or simply put diff minutes, and that's the different time difference in minutes. Awesome. So this is how it is set up. We have uh, we have the time that it takes to go from this station Eastchester to Baychester is 2 minutes. Baychester to Gun Hill Road 2.5 minutes, and so on. And this is awesome. So what we'll do next is we'll try to find the time differences between station across all trip IDs, and then try to pull the difference in minutes for each similar combination. For example, we may get 50 values for Eastchester to Baychester, and these values may vary. It could be 2, 2.2, 1.5, etc. And we'll try to see if there is if it happens such that the time difference is 10 minutes. And that's when we know that it's a delay. Awesome. Let's now run this query on a more number of rows. Uh, so we just had these two trip IDs. I think we can now run this on more number of rows and see what we get. So for the limit, we can maybe set this to 1000 and then comment out these two lines and then run this. But after we run this, what we are interested in finding is how many times do these stations repeat. So what we'll do is let's first run this and see what we get. Invalid time string. Oh, right. So this is an issue that we have faced earlier, and if you remember, we created the sort of rewrite. We did rewrite parts of these and performed the conversion to time. We could do that here, or we could simply ignore these records which have invalid time. Before we do any of that, I'm just curious to see what trip ID that what that trip ID looks like, and so what I'll do is pull the records from the table from, and here I'm going to use the stop times table so that we get that time, and once we have that time, we uh, we can we can try and see what the trip looks like, where where arrival underscore time is so we'll use regular expression. So regex contains contains regular expression contains arrival time, and then we put a comma, and the string we are looking for is 25 colon dot star colon dot star, and that that's that. So let's run this, and we only need a couple of these, so let's limit this to 3 records. Run this, and hopefully we'll get a trip ID. So that's the trip ID, and we'll pick one of these trip IDs, copy that, and use that in the where up here, and we'll say uh, where trip underscore ID is equal to we have this, and we'll run just this inner part of the query so that we can see what trip we are looking at that has this time which is 25, and here it is. So the trip did start at, it looks like it started at 25 and then went all the way up to, it's still 25, but it could have gone to 26 or 27, and there are 38 different time points. So if we delete this, we are going to lose a lot of data. So we don't want that to happen. And so I think it will do one thing. We'll convert this to a time. For example, if it's 25, we'll change this to 5 hours after midnight, and if it's and so on. Hopefully that will work, and so we can try to do that right here. So what we can do is say comma, and all we need is, let's just use the arrival time column, and here we'll create a new column and we'll use regular expressions. We'll say regex p, and if this contains, or if contains regular expression time arrival underscore time, if this contains the string as in 24 colon and dot star colon dot star, or uh, as we have seen before, we could write 25, 26, 27, so 25, 20, 26, 27, and that should work. If the regular expression contains this, then we are going to replace the value for 25. So we'll say if this happens to be true, then we are going to we need to replace the initial part, right? So we will have to replace the initial part, and uh, so what we'll do is we'll get a substring. So we'll say sub str, and we'll concat those. So we'll do this. We'll concat. Uh, if that's the case, we'll concat the difference between um, this value and 24. Right? So concats sub str arrival underscore time. We need the values from 1 to 2. We're going to cast this as an integer. We'll say int 64, and once we are done, once we do the casting, so that's the substring, that's the uh, integer, and then we subtract this from 24, and once we do that, we again need to cast this back to a string before we do any concatenation. So let's see if the parentheses are correct. This goes with that one. So that's the cast this as string. Okay, so that should work. And let me check this again. We have the substring, so that does the substring part. This should be as, not a comma. Okay, and again this needs to be an as, not a comma. The next part is substring sub str, and this is going to be again arrival underscore time, and we are looking at the string part of the string that goes from 3 comma, so this is 1, this is 2, then we have 3, 4, 5, 6, 7, and we have 8. So we go up to 8, and that's what we want to do. If this exceeds uh, 23, if it exceeds 23. Now if we get a value of 24, it will get reset to midnight and so on. And if that is not the case, we can simply return the arrival time as is, and we can rename this as maybe a new arrival time, or we could simply keep this as arrival time. But for now, we'll call this as a time, just to see if what the code that we have written does really work. And here is what we have. Oh, that's because we have put a 3 there, limit of 3. Put a star, then a comma, or just leave that as is. Run this query, and we should see all the times. So this is what we have. We have 1, that is 1 hour past midnight, and this looks manageable now. This should resolve the error that we had. And what I'm going to do now is copy this part of the code and paste it in here where we start working with the time. And arrival time, this is partition by, that's fine. Laggerl. So I think what we should do is, instead of using arrival time as is, maybe it would help if we could make the changes right here. So we'll make the changes at the very beginning, so later we do not have to use or cast things again here. So this should work seamlessly. Awesome. Now again we can comment this out. So we'll use a multi-line comment like so, and run this query again. Hopefully this should have sorted out the problem of arrival time. Unrecognized name, arrival time at 18, and wonder why that is. Arrival time. So we have the arrival time. Oh, this is arrival time. Arrival underscore time. Run this again. And this did work this time. We have the station, stop sequence, difference in minutes. So we did, the calculations did work this time. Fantastic. So now we'll remove the filter for the trip ID that gave us the incorrect arrival time. This was, let's put a note here. Arrival time, this was 25:00:00. Arrival time issue. And if we run this entire query, I should have put a stop on 1000 records. We'll see how this goes, and it did run. So no issues with any errors. Everything, we got the 500,000 records processed. We now have the difference in minutes for between stations. This is awesome. We have 60. Let's look at this one. 66th Street. So we go on the map and look for 66th Street. We can put this maybe in quotation. That will help find it as a complete string. No? Okay. How about we just type 66 and look for 66. I'm not seeing 66 here. Oh, I think I found it. There, here it is, 66. So that's 66th Street, and the next station is Lincoln Center. 66 Lincoln Center, and the next street is 59th Street, Columbus Circle. Okay, 59th Street, Columbus. Awesome. So we have, we now know how much time it takes to go from Lincoln Center to the Columbus Circle. That's fantastic. And how much time it takes? It takes around 1.5 minutes. If we think about this particular column that we just created, if we are going from Baychester Avenue to Gun Hill Road, that will give us another one time. And then going back from Gun Hill Road to Baychester Avenue, that will give us another time. So we should be assuming that the distance between going from Baychester to Gun Hill Road and going back from Gun Hill Road to Baychester Avenue, the distance stays the same. The tracks are almost identical and parallel, same distance. So what we need is a string that is identical, so that we can perform a group by. And so rather than having these two separate strings, what we actually need is this. We need a string that is this, and rather than having a string that looks like this, we need a string that again sorts this string, and we get this Baychester Avenue in front because we have the letter B there, which will come before the letter G of the Gun Hill Road, and then we can perform a group by on these two strings. So for that, we'll comment out the concat statement, and instead we'll write array and square brackets. We'll say lag underscore station underscore name, comma station underscore name as s1 underscore s2. Now with this, we also need a way to need a way to sort this, and for sorting this array, what we can do is use a nest. And let's say this is the array. This is the array. Let's try and see if we can do it in the same line. We'll put this inside of square brackets, and we'll say unnest this, and we'll say unnest this. But before that, we need a select statement. So we'll put all of this in a select. So we'll say select, let's say x from unnest this, and we'll call this x, and then we'll order this, so order by x. So what that will give us is that will order the names in that array, and then we again need the output as an array. And after this, what we need is a way to convert the array to a string. So we'll say array underscore to underscore string. So that should give us an array that is sorted. But we have an error. Let's see what there's no matching signature found for the function array to string. Array to string. Maybe I missed something. Oh, string. That looks okay. And then we have this array, which is the bracket ends here, so that is fine. Then we have this square bracket or the parentheses that's there. Let me go ahead and just check in the docs for array to string. That's for the BigQuery. I just need to make sure that the syntax is on point. Array to string. So we have the list. Oh yes, so there's one thing missing, and that is we need to give a separator. So for separator, I'll put a space, pipe space, and that should take care of this. Now when we run this, we should get a nice string that is sorted. So we have Baychester Avenue to East Chester and Baychester Avenue to Gun Hill Road, and likewise if there is this similar station, we should be able to see that. So if we go back to the map, that's Baychester, that's East Chester, and then we have the Gun Hill Road. So the station is in between these two. Awesome. So with this, we are now in a position to perform a group by, and to do that, we'll put all of this in another CTE. Let's call this CTE station or let's say station, and then or we can say time diff as but we already have something. Let's call this simply ABC, unless we have ABC also somewhere. No, we don't. Okay. So as this, and then hold on here. The name should be informative, so why not try to get a good name there. Yeah, we can say that this is station time difference. Okay, so that makes that is more intuitive name. Okay, now the final phase of this query is what we could do instead is we'll create another CT called stat as or let's say mean or AVG STD, and this particular the values for this would be, we'll just need the S1 S2 because we'll perform a join later on using this column, and we'll calculate two values. One is the average value, and then we'll also calculate the standard deviation, which is this for the minutes. So we'll say average diff, and we'll say the second one is standard deviation for the diff column, and let's call this average diff, put a comma there, from station underscore time so that should be good. uh, because the average for that entire string is going to be the same, standard deviation is going to be the same, so we should be able to perform a join this way. Next, we'll take select, and this time we can choose again S1 underscore S2, and then we can calculate the z value. So we say diff underscore minutes minus average underscore diff, and then we can divide this by std underscore diff, as this is, let's call this z score, or let's just call it z score for now, and this is going to be from the station name diff. So that's this one. We're going to perform an inner join AVG STD using, and here's where we'll use the S1 underscore S2 for this, and this is going to be let's abbreviate this as ST, or just ST, and then we'll pull this value from ST, and again the diff value will pull from ST. The other values would be coming from this particular AS, and or we cannot use AS, of course. We can use AG maybe, and so AG will pull this value from AG, pull this value from AG, and using S1 S2. So that should work. We should start seeing values for the Z score, and we can round this as we have done before to maybe 2 decimal places, and we can run this and see what we get in the output. Well, we have all values are null, and likely because the number of readings per string are much less. Why don't we perform a same thing on the entire data set, remove the where and go back, and here what we can do is perform an order by. So let's say order by z underscore score, and run this now. It might take a few seconds. Division by 0, and that is a reason because we may have some data where the count for the for these averages is just, there's just one value, so standard deviation cannot be calculated, and that's what's causing the division by 0 error. And if that is the case, then what we could do is uh, we could simply, we will have to put a filter uh, that takes care of that, and to do that we can do that filter right here. Before order by, we can say where ag.std underscore diff is greater than 0, greater than 0.0, and run this again. If you still get an error, I will have to go back and see where the code is crashing. Wow,
Wow, these are pretty high values, and now it makes me wonder if those are correct. The 35 is that's the highest value I was expecting was maybe around -3, -4, or +3, +4. But these values are huge, and wonder why. So this is 103 to 96th Street. Let's go to 103. 103. That's 103 to 96th Street. So this is the station, and oh well, why the okay. Here's another thing that we could do is we could also we already have we could also get the average difference. So let's do that. AG dot average diff, and we can also get the let's also get the standard deviation in there. So what we can look at is what's the average value, what's the standard deviation, and then do those these values these value make any sense. These values still, so the average time it takes to go from this station to the other one is just it's just 1 minute. Now the standard deviation is very high. That tells that sometimes the delay, there are delays, so it probably takes a lot more than 1 minute. And so what we could do is add another get these values. So why not get min value for diff underscore minutes as this is min diff. So that's one, and I'm guessing sometimes these cannot be zero. There has to be some value. Min diff and then max. These are the values we are interested in. Max minutes as max underscore diff, and let's get the same values out here in the output. Min ag. So we'll pull this from ag min underscore diff, and then ag dot max underscore diff. Okay, so this should give us some idea as to why we are getting so high values for z score. Okay, and here is the, so there is obviously something wrong with these values that were calculated. So this is saying that the time difference is 14:38 minutes, and I guessing the reason is because up here where we did the regular expression, there is 20 incorrect time issues. Those are probably something that is creating this issue. We have, yep, that's what this is suggesting is the problem. And not sure why. So because if you look at the max difference is pretty good. 0, 3 minutes, 5 minutes, nothing out of ordinary. But the mean difference is way for different magnitudes. So let me go back and look at the code and see if there is any fix needed. All right, so I found the problem, and the problem was this. Uh, Sometimes let's say if the train starts if we cross the midnight, that's I think where the problem could come in. Let's say if we have a arrival time that is 2300 hours, 58 minutes, and then by the time it reaches the next station, it's let's say after midnight, and so that's where the difference would be 23 minus 1 or 23 minus 0, and that's probably causing those high values. And so what we can do is this, that's here. If the values are, if the lag arrival time is greater, which it should not be, but if it is, then we that's when it crosses the midnight 0 100 hours, then we perform the calculation like this. else we leave it as it is. And so with this change, the uh, the code runs just fine. And additionally, I've added another uh, count here. And so the reason for adding that count is so that we can also see how many values are there for that particular combination of station, those two stations. And so now when we run this, we get reasonable values for each of the combination of stations. So let's say Borough Hall and White Street. Let's see where it is. White, Control F, White Street. Let's see, let's just look for White. That's White Street right here, and that's Borough Hall. So this must be this probably this is either the red or the green, either of those two. Those two should be there, and as we can see, there are around 1442 trips that include those two stations that have passage from those two stations, and the minimum time it takes to get from one station to the next is 1 minute. The maximum time is about 1.5 minutes, and you see that the z-score is pretty high, and that's the reason because we have these count number of trips is a lot higher. And if you are interested, this we could try and plot this, and we'll see. But these are high values, and these it is the data is sorted accordingly. So if we put, let's say, 200 values here, you'll see that anything above plus minus 3, I would say, would have been a candidate for some kind of approaching the delay problem between those stations. But here looks like all of these are above plus minus 3. So this is all below minus 3, and um, maybe these stations do need some uh, work. But if you look at the values, the difference is in seconds. It's not in 10 minutes or 30 minutes. At least in this there's we have a 1.5, maybe 30-second difference, or here we have 30-second difference, or here we have 30-second difference. Not much going on there. So what we could still do is we could get unique values for these. So let's do that. Get unique values, and for getting the unique values, what we can do is just uh, rather than getting, now that we know that all this exists, we could maybe just get a distinct on the stations, and maybe the z scores, and the rest of this we could simply comment it out. We can maybe comment out all of these values. I'm still interested to see how the distribution looks like. Maybe there will be just 2 bars if there's not much going on there. Run this, and we should now start seeing uh, the values that are below or between plus minus 3. I hope we see those values. Yeah, so these are the values that are below. So these are yeah, these stations are in pretty good shape. So to answer the question of delays, as it's uh, you would say there's something you can think about is uh, like practical significance versus statistical significance. Is 30-second difference really practically, does it matter that much to do some major changes or overall in the transit system, or is that reasonable? If 10 minutes was the delays, then it would have been a big issue. But I think everything is running fine. Uh, let's look at least based on this data set. Let's I'll put this as final as, and then what we could do is the following. We'll filter out the z-scores and according to the values and look at the stations. Why don't we keep all the values here so that if we need them later we can always pull them. Select star from final where z underscore score is greater than, let's say, minus greater than 3 or z underscore score is less than 3. That's oh, or my mistake. Greater than 3 or less than minus 3. And run this. So this should give us the list of all possible stations that have values that are outside this box. And here we see these are the plus values, and of course these are not ordered. Aha, here are some stations that have some problems. As you can see, difference in minutes is 149 and minimum difference is 2. So these stations looks like they do have some problems. 119 minutes, and that's how many seconds? So 120. So that's around 2 hours delays on this line, Central Avenue to Myrtle Avenue. And let's say Central Avenue, we know where Myrtle Avenue is. It is somewhere here. That's Myrtle Avenue. And where is Central Avenue? Central Avenue is right here. So this part, according to whatever we have found here, it says that there are delays between these two stations, Central to Myrtle Avenue. And then not sure if there can be so big delays, like Canal Street to D Culp Street. Canal Street. Here is Canal Street, and then there is the other station is D Culp Street. So Avenue. Let's search for that. And do we have that station on the map? Oh, right here. So Canal Street to, oh well, okay. So that's a route there, and it's the distance. It's a long distance, and what then in this case, as you can see, the data you have to look at it carefully. It takes around 8 minutes, but sometimes it takes uh, way longer than that. These numbers are very high, and if you try to calculate, I'm going to work these out on my calculator. 539 minutes divided by 60, and that comes out to 8.9. And so 8.9 hours delays. So is that the case? We do not know. So let's do a Google search and see delays in NY subway transit, some NY subway, and see if we get any hits. Doesn't capital commuter alert, subway, NYC is delays, and um, delay. Let's search it this way. Delays in subway between. So let's see if there's anything there. Rain breaks. How? Maybe it could be this. So if there is rain or snow, maybe during that time the trains are delayed substantially. And here doesn't say much. In line is the train running. That's the current status. Uh, New York NY subway. What routes experience most delays? And I just wanted to see if those routes match with what we have. New York subway delays worst for low income. Okay, go back and look at what the if they have any stations mentioned here. Subway, get to work, Manhattan. Train to leave further researchers. Reserve Bank. Study found that New Yorkers in high-income West Side apartments experience fewer subway delays. The commute to lower-income neighborhoods was delays, including Coney Islands, Harlem, New York. Okay, and then we have Coney Island. Don't know if we have that here on the map. Coney Island, and then the second one was uh, Harlem. Let's search for that. Harlem. So these two stations. So those are okay. Those are there. Why do most surveys have delays? So let's see what they are talking about here. And doesn't say what stations. We are more interested in the say station. What stations? Human cost of subway delays. And then we have transit crisis. Okay, maybe this has something listed. Subway. Let's look for subway. And let's see, can find anything. Doesn't say much. At least if we read, maybe we'll find something. Let's search for Canal Street if that shows something. Nope, nothing for Canal Street. Not, let's search for this particular word. It doesn't say anything. And how about we search that again here? Delays. Route N Canal Street. Here, oh, there's nothing in particular that we are seeing, but based on the data that we have, uh, this particular we could get the max diff column. We could sort it on max diff and see uh, what all stations are there. So let's do a order by max underscore diff. Run this again. But we should have sorted it descending. We'll see. And max diff, that's 0. And let's sort it the other way around in a descending form. EESC, run this again. And we'll find out how this is. Okay. So there are some, so the values are pretty high. We have 600 minutes, 500 minutes. So these Beverly Road and Church Avenue, where is it? Beverly Road and Church Avenue. So between these two stations, they are pretty close, but So most of the time you'll see that it's 1.5 minutes, but sometimes there is 689 minutes. Now another question that you to explore would be what are the days when there is such a high time difference, or are those weekdays, or is it something different? And if we keep going, here we have mean time 8 minutes. These are long distances. Canal Street, same here. This is Grand Street, same. And these are far out stations, looks like. These are all 8. So there are several stations that experience delay. So uh, where it takes around just 1 minute or 1.5 minutes to go, uh, here it's taking around 89 minutes. 89 minutes, so more than an hour. This is what 103 Street and Cathedral Parkway. Let's look at 103. 103. That's right here, and Cathedral Parkway. So between these two stations, that's where. So it could be the route we do not know in this case, but if we plug in the routes, we will be able to find out if it's this route or this route. But nevertheless, we know that if there is something to be done to uh, improve the customer service or commuter experience to avoid delays, then these would be the routes or stations that one should look for. And that answers this question that we are trying to get at is uh, around delays as to if you are asked where what station should we look at or what route should we look at, then now you have the information between which station the problems do exist, and these are the stations. If we try to explore this, let's export this to Google Sheets, and hopefully that'll we'll be able to scroll down and look at a lot of data which we cannot do there in that output table. So here we are in the Google Sheets, and this is the data. We can move this to the side and continue looking at these numbers. And as the news that we just read, the blog that we just read, there are these stations where the delays are least. So which are these stations? Avenue 231 238 Street. 231 to 238. Let's see where that is. 231, 231, 231, 231 to 238. So these stations don't experience any delays. Those are, but my guess is this 251 to Marble Hill or 225 must be experiencing delays. We'll search for Marble in this particular. There's nothing for Marble. Let's search for 225. There's nothing for 225 either. How about 215? Let's see if we have anything for 2. There's nothing. Wondering if the search. No, that's probably not doing any search in this notebook. That's options. Maybe if we do a Control F on this, doesn't work. All right, that's what we have. These are the that's search avenue. So this answer. So if we want to spend some investment amount, or if we want to improve the condition of delays, so there are lesser number of delays, then the suggestions or recommendations would be to look at the transit between these stations that have these exceedingly high wait times that are in hours. Is we could see if we can plot these values somehow. So let's try do that. What I'll do is the output that we need is we need the raw values. And so we need the raw, rather than getting the average values, we need the values from this table, which is the station time diff. And what I'll do is comment this out for now. You already have this written, so I'll comment this out, and then below this we'll say select star from, and here this is the table that we are going to use, and from that table the tables sorry, the information that we are looking for is, or maybe we need this one. The information that we are looking for is the difference in time, diff minutes, and the string, the sorted string s1 s2. So let's do this then. S1 underscore S2, that's the sorted string, and then we need the diff time. So we put that here, diff minutes, diff underscore m minutes. I think that's what, yeah, diff underscore minutes. Now this will give us the entire data set with the difference in minutes. With all the values with duplication, and that's what we are going to use to uh, to plot the values. But this is, yeah, it is sorted or it is not. Let's sort these values as we pull them by the s1 s2. So order by s1 underscore s2, and this again. So let's see if we can open this in Jupyter Notebook. Okay, so that's what we have. I run this. Job loaded. Results.describe. And we could import numpy as np, import pandas as pd, import matplot, allow notebook to allow. Okay, that goes into sign in, this account, allow matplotlib dot pyplot as plt, and let's see results dot head. We should see the results. Okay, so we have that, and what we'll try to do is plot these. So we'll say plt.hist, and we'll do the results. Of course, before we do that, we'll create a df is equal to results, where we are filtering these results, and we'll say results s1 underscore s underscore s2, that is equal to this particular string, which is the combination of stations we had created, and those are the only results we are going to take for plotting. plt.hist df, and the column we would like to plot or get a histogram for is this one, df minute, and we can say plt.show. So as you can see, there's essentially just two data points we have. There's not much of a distribution that we are expecting. Let's look at what we could do is comment this out again. We now have, because we now have the data, we can go back to our original z-score output and look at the stations. The one that we are interested in was that the canal station, and look at the distribution, why or how the values are so in such a big range from 1 to hours. So again, we are here, and I'll go ahead and change this name to this station and copy this. Let's create another cell, paste that here, maybe revert this back to what it was, run this again. And so we do see that maybe there are just one or two values that are higher than few minutes. So if we look at this results table, and if we say get me all the values, uh, get me all the values from diff underscore minutes, or we can do this, comment this out. This is 1, and we'll put another condition there, and results diff underscore minutes is greater than, let's say, 10 minutes. 10 minutes. And how many these are? So dot shape. So we are interested in just the number of. So there's just two values. No, there's 0 values. Why is it 0? And if underscore minutes is greater than 10, okay, we could put this under in here. Okay, so there are 21 values. Now let's see what those are. These are 21 values. So greater than 100, let's put a 0 there. Let's say how many times was the time greater than 100 or 60. There's just two occurrences. So what we are seeing here, is this 689 hours of delays. That doesn't happen always. From 1000 trips, that high delay was just one or just two times, and that's not a big concern, I'd say. But for most part, the delays could be of the order of 10 minutes or 11 minutes, but still that is much less, as you can see. uh, and not There are only 21 such trips that had those delays. Let's say ballpark, if you look at these numbers, we have 1005. So 1005, and let's say if 21 of those trips were delayed, divided by 1055, you get this, multiply this by 100, have, so around 2% of the 1.9% of the trips were delayed, other trips were on time. That's impressive. I mean, I wouldn't worry about one or two delays there. Additionally, if we try now to plot the values based on this additional filter, so what we could do is we'll put that difference in minutes also in place, and then run this. Start seeing that these are the values that are there, and I'll say less than 10. Maybe we'll see here is we start seeing the distribution, you see, but it is completely skewed, and most of the data points lie around 2 minutes mark. If we put this to 3, less than 3 minutes, and that's what we have. Most of the trips have a time, so the most of the trips take around 1.6 minutes to get from Beverly Roads to Church Avenue, and vice versa. Let's look at another Beverly Hills and Church Avenue. Can we look at that in the map? Let's see, Beverly, Church Avenue and Beverly. So these two. Sometimes there are delays, but most of the time there are no delays. Everything runs just fine. How about we look at some other station? How about this one? The Canal Street and this the second copy. Paste that here and run this again. Oh, no values there. So why don't we comment this out? Run this again. And as you can see, those are the values. Let's put these here and look for values that are greater than 10 minutes. So there are 14 entries. And a similar picture, there were 1, 2, 3, 4, 5 occasions where the train was delayed substantially. So for, let's say around 500 minutes. So if you divide that by 60, you get around 8.3 hours, 8 hours delay uh, uh, on five occasions. Otherwise, the delays are 10 minutes, 12 minutes, etc. And if we try and plot those values, let's say less than 10, and run this. Here is what we get. So most of the time it takes around 8 minutes to get there. Sometimes it takes little more than that, and that's exactly what we had here. So minimum it takes 8 minutes, and the maximum uh, it it can take an hour. There's no upper limit, but on an average you'll be in the range of 8 to maybe 8.8 or 9 minutes to get there. Cool. So that's all I wanted to share in this particular project on SQL, New York subway data that we analyzed. I hope in this particular data set you got a nice intuition on how to get started on the data set, then how to look for problems, and then based on the data sets that we have, can we try and answer those find insights to answer those problems or answer questions that can solve those problems. We have written code in sequential steps, and in this video the code that we looked at was essentially trying to uh, find an answer to the delays, like to find the stations between which there are delays, and we found that as we can see, and we did that despite not having the arrival departure times on stations. We looked at the sequence and we were able to find those delays between stations. Awesome. You could explore this data further, and if you come up with some exciting insights, please feel free to share them in the comment section below. Meanwhile, if you have any additional questions, please also feel free to post them in the comment section below. Thank you, and I hope this project helped you to get started on your journey into SQL projects to improve your SQL skills. You could dive much deeper into this same data set or maybe append other data sets to this data or work on similar data sets to create projects that you can put in your portfolio for SQL skills. Thank you so much. I hope you enjoyed learning with me as much as I did enjoy writing this code for you guys. Thank you and bye for now.